Good day, my dear mathlets. Today, I will introduce or enumerate some of my students' misconceptions and common errors, particularly in the concepts of factors, prime factorizations, and others. For the first error I encounter is that students sometimes use decimals as factors of a given number. Say for example, they say that 2.5 is a factor of 5 because 5 divided by 2.5 is equal to 2. That means 2.5 divides the given number evenly. So considering the fact that 2.5 divides 5 exactly, yes, it does, but 2.5 is not a whole number. Rather, it is a decimal. So we cannot consider that one a factor of 5. The second misconception is that students believe that there are numbers without a common factor. Take note that the factors of 2 are 1 and 2. The factors of 4 are 1, 2, and 4. And the factors of 5 are 1 and 5. If you come to look at that, their common factor is 1. Therefore, all numbers have common factor, and that is 1. 1, ladies and gentlemen, is still considered the lowest factor of any number. The third one is that students believe that factors of a given number must be smaller than the given number. They do not realize that the number itself is a factor. Say for example, for 12. They know that the factors of 12 are 1, 2, 3, 4, 6. Some do not realize that 12 is also a factor and that 12 is not smaller than itself. Rather, they are equal. For our error number 4, students believe that 1 is a prime number. In order to be called a prime number, it must have two positive divisors, and that is 1 and itself. In the case of 1, we are only considering one divisor, and that is 1. No other divisor, so we cannot consider 1 a prime number. Much more for a composite number, because when we say composite, these are numbers with 2 or more positive divisors. That's why our 1 is neither prime nor composite. Rather, it is a unit number. And for our fifth misconception, students believe that an even number is automatically a composite number and an odd number is a prime number. Before that, let's define first. When we say an even number, those are numbers that are divisible by 2. Or those are numbers that ends with 0, 2, 4, 6, and 8. And when we say odd number, those are numbers, or when we say odd numbers, those are numbers that end 1, 3, 5, 7, and 9, or those are numbers that are not divisible by 2. Now, to contradict this statement, say for example, the number 2. 2 is an even number, but it is a prime number. Why prime? Because the factors of 2 are 1 and 2 only, or 1 and itself. By the definition of a prime number consists of 2 positive divisors or 2 factors. That is 1 and itself. And the other statement would say an odd number is prime. Say for example, your number 9. 9 is an odd number, but the factors of 9 are 1, 3, and 9. Therefore, not all even numbers are composite And not all odd numbers are prime. There are exemptions for that. But the only even number which is prime is 2, and that is the smallest prime number. For our sixth common error, that is, students believe that greatest common factor and least common multiple are alike. Students would say that GCF is just equal to the LCM. Unfortunately, they are not the same. When we say greatest common factor, we are pertaining to the factor. And when we say least common multiple, we are pertaining to the multiple. Afterwards, I will present the difference of the two. The last one is that students believe that a GCF is always greater than the value of the LCM. To illustrate our sixth and seventh misconception, let me just present to you on how to differentiate our GCF and our LCM, or the greatest common factor and the least common multiple, by differentiating them with their definitions and how to solve them using two different methods. So the first method is using your prime factorization or the factor tree method. So for GCF versus our LCM, so we will put a barrier in order to differentiate them. So when we say factor, it is a number that divides a given number evenly, as I have said earlier. And when we say multiple, it is the product result of one number multiplied by another number. Say for example, the factors of 2 are 1 and 2. And the multiples of 2 are 2, 4, 6, 8, 10. Because those are the product when you multiply 2 by 1, 2 by 2, 2 by 3, 2 by 4, and so on. So for our example, we would like to show the solution using prime factorization by finding the GCF and LCM of 12 and 18. So we will be using the same examples. So by prime factorization, we factorize your 12. So what are the factors of 12? We can have 2 and 6. Since 2 is already a prime number, we can encircle that 1. And 6 is still a composite number, so we need to factorize that 1 still. So the factors again of 6 are 2 times 3. 2 here is already a prime number, so we encircle it. And also 3 is a prime number, so we can encircle it. Therefore, the factors of 12 are 2 times 2 times 3. And the factors of 18 are 2 times 9. So 2 is already a prime number, so we encircle that 1. 9 is not yet a prime number. It still have factors, so we need to continue. The factors of 9 are 3 times 3. 3 is a prime number, therefore we stop from there. Then the factors of 18 are 2 times 3 times 3. In order to get the GCF, we will box your common factors. So the common factors are 2 and 3. So the GCF, you bring down the common factors or the numbers in the box as 1. So we have 2 times 3 is 6. Therefore, the GCF of 12 and 18 is 6. For the LCM, we do the same. Alright. In here, we put in a box the common factors, so that is 2 and 3 again. But for the LCM, we bring down as 1 the common factor, so we have 2 and then 3. And then we also need to bring down the distinct factors, the 2 other factors that are not in the boxes, that is 2 and 3. So we multiply them all. We have 2 times 3 is 6, times 2 is 12, times 3 is 36. So there you have it, their difference. The GCF is smaller than the LCM. So going back to our misconception earlier, not all GCFs are larger because of the word greatest, and not all LCMs are lesser because of the word least. The next method that I wanted to introduce is the Tic Tac Toe method. If you know the game Tic Tac Toe, that is a box, right, that you need to complete. Seems true with finding the GCF and LCM. In order for you to further differentiate them, we can solve that one using the Tic Tac Toe or continuous division. So we can have an L-shaped figure, and using the same example, of course, in order for us to see their difference well. So we have 12 and 18. First, you have to think of a number that you can divide from 18 and 12 and 18, or you must think of a divisor of both 12 and 18. So that is 2. You can also have 3, but I wanted to start with a smaller one. So 12 divided by 2 is equal to 6. So you put it on the bottom of your 12. And 18 divided by 2 is equal to 9. After which, since 6 and 9 still have common divisor, and that is 3, we still need to continually divide that one. So 6 divided by 3 is equal to 2, and 9 divided by 3 is equal to 3. 2 and 3 now are both prime numbers, and they do not have any other divisor in common, so we can write 1 there, because as I have said earlier in our misconceptions, 1 is still a common factor. For the GCF, we consider the numbers that are vertically written. So we consider 2 times 3 times 1, or we could just write 2 times 3. So 2 times 3 is equal to 6. And for the LCM, we copy the last numbers we wrote, and that is 2 and 3. And then we consider the L-shaped one for the LCM. So our clue is the L shape for the LCM, and for the GCF, our vertical shape. So that is 2 times 3 times 1 times 2 times 3. So we may not write 1 na, since all numbers multiplied by 1 is equal to itself by your identity property. So 2 times 3 times 2 times 3 is equal to 36. So I hope I differentiated our GCF and LCM well, and I hope I corrected some of the common errors we encountered. For our next video, we will be dealing more about the different factoring techniques, and for our English videos, more on our MELC Grade 9 English. Thank you so much, and have a good day.